Good afternoon, everyone. This is Henry from STEM Tutoring once again. Today's lesson will be on some basics of electronics and how electrical circuits work. The first thing I will talk about in this series will be how to combine resistors in series or in parallel, something all good electronics students must learn. And those of you taking physics, when you study electrical circuits, you must learn this as well. So, suppose we have, whoops, not that, this circuit. We have a voltage source here with two resistors connected in the same path. So like pipes connected end to end, the current flowing through both resistors is the same. That's why this connection is called series. Suppose this resistor is 10 ohms and this one is 25 ohms. If I want to replace both resistors with a single equivalent resistor, then I would simply add up the individual resistors. So in this case, the equivalent resistance Req equals 10 ohms plus 15 ohms. I'm sorry, plus 25 ohms. 25 ohms, which equals 35 ohms. So this formula works for series connected resistors where the current through both is exactly the same. So they're flowing in the same path. So that wasn't too bad. Now let's look at another case. Oops. Let me just erase this whole thing here. So what about the other option, a parallel connection? So what about a parallel connected circuit? So let's suppose we have this circuit instead. Again, we have a voltage source. Now the two resistors are in two separate but parallel branches. The voltage across the two resistors is the same. This is a parallel connection. So let's say this resistor is 10 ohms and this is 25 ohms. The formula to remember here is that 1 over the equivalent resistance Req is equal to the sum of all the reciprocals of the resistors that are placed in parallel. So in this case, that'd be 1 over 10 plus 1 over 25. If I had 3 or more resistors in parallel, I would keep adding the reciprocals of the individual resistors. And that total of all the reciprocals would equal the reciprocal of the equivalent resistance. So if I simply cross multiply to get a common denominator, we have 25 plus 10 over 10 times 25. But that's the reciprocal. So we have to flip it to get the actual equivalent resistance. Here, Req equals 10 times 25 over 25 plus 10. I wrote it this way to illustrate an important point. When you have two resistances in parallel, the equivalent resistance will be the product of the two resistors over the sum of the two resistors. That will always work whenever you have two resistors in parallel. If you have 3 or more, then you have to resort back to this formula. Now, what if both resistors are the same? We'll call them R. Then that would give us an equivalent resistance. So for example, if we had this circuit here, and these resistors are both R. That would give us an equivalent resistance of R squared. R plus R is merely 2R, and this reduces to R over 2. This is also an important result to memorize. If you have two equal valued resistors placed in parallel, the equivalent resistance will be exactly half of one of the individual resistors. So now you know how to combine resistors in series or in parallel. Hopefully this helps you next time you study electronics or you're studying electrical circuits when you take physics. If you'd like to learn more, I'm available for hire as a private tutor. You can look me up on my website or send me an email that's placed right at the top there. I'll circle it. The first 1 hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding value in helping you succeed. And as a thank you for watching all the way to the end of today's lesson, mention the code FREEBOOK when you contact me. And at our first tutoring session, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, especially high school students and college students, to succeed in school, in work, and in life. Thanks for watching. Have a good day.